Good morning, all of you. So in the previous class, we discussed about introduction to knowledge representation. After that, we discussed about approaches to knowledge representation. In that, we discussed about various types of approaches for representing the knowledge. And there we have discussed 4 approaches. First one is relational knowledge. Second one, inheritable knowledge. Third one, inherence knowledge. And fourth one, procedural knowledge. In that, we already discussed about all this. So relational knowledge, we discussed about relational knowledge, inheritable knowledge, inherence knowledge, and procedural knowledge. And we also discussed about knowledge representation using semantic network. Okay. Let me share my screen to you. Okay, so knowledge representation. So knowledge representation using semantic network. Okay, in that we discussed about we discussed one example. Okay, right. So in that this is the sentence given to us, or this is the example given to us. So every human, animal, and birds are living things who can breathe and eat. All birds can fly. Every man and woman are human who have two legs. A cat has fur and is an animal. All animals have skin and can move. A giraffe is an animal and has long legs and is tall. A parrot is a bird and is green in color. So these are the so this is the knowledge given to us, right? So based on this, we have to represent the knowledge using semantic network. So this is the semantic network. So like this, you have to represent. Okay, like this you have to represent, right? Next. So right. So here, so living thing. So first one is what is the first knowledge given to us? Every human, animal, and birds are living things who can breathe and eat. Now let me consider one thing, that is living things. So all these human beings, animals, and birds are living things, right? So let me consider living thing. So under living thing, three things will come. One is human, next one birds, and next one animal. These three will come, right? Next, another property for this living things are they can breathe and eat. So for living things, we have to consider can eat, can breathe. These two, right? Can eat, and can breathe. Okay. Next one. Right. Next one. All birds can fly. Rohit. Rohit.
ఏం చెప్పు
వస్తావా లాబీకి?
ఎట్లా నువ్వు A square B square C plus D whole. ఎరా అస్సాము
ఏంటి
ఇదేడి గోల్డ్ ఏడి
ఎవరికి తెలుసు?
క్లాస్ ఏంటి స్టార్ట్ అవ్వాలా? క్లాస్ విందాం నేను వస్తే.
క్లాస్ స్టార్ట్ అవుతుందంటే
Okay, sorry for the disturbance. Okay. Okay, so this is the knowledge given to us. Every human, animal, and birds are living things who can breathe and eat. So all birds can fly. Every man and woman are human who have 2 legs. A cat has fur and is an animal. All animals have skin and can move. A giraffe is an animal and has long legs and is tall. A parrot is a bird and is green in color. Right. So this is how to represent the knowledge using semantic network. Okay. Right. So first, all these human, animal, and birds, all these are living things, right? Right.
oh, living thing, right?
Who's that repeating the things? Don't you have manners? Please listen to the class. Don't disturb the class.
Okay.
Right. So, yeah. So these are living things. All these human beings, animal, and birds are living things, right? So first let us write living things, right? Living thing. Next, and its properties are breathe and eat. So they can breathe and they can eat. So that's why I have written this living thing. They can eat, they can breathe. Right. Next one. All birds can fly. Okay. Let me come to birds. Here I had written three things. One is human, birds, and animals here. So human, birds, and animal. Right. So here all birds can fly. Let us come to let us come to birds. So birds can fly. Okay. Next, every man and woman are human who have two legs. Okay. So every man and woman are human who have two legs. Okay. So two things will come here. One is man and woman. So woman is a human and man is a human. That's why I related it with easy relationship. Right. Next one. Next. But some but something is missing here. Here I cannot represent a woman and man that they have two legs. Okay, that one is missing here, right? Next, so a cat has fur and is an animal. Let me come to animal, right? A cat has fur, so and is an animal. So, right. Next. So cat is an animal, right? Next one, all animals have skin and move. All animals have skin, so that means I can write it as has skin and can move. Next one, next, a giraffe is an animal and has long legs and is tall. Giraffe, animal. Let me come to animal. So giraffe is an animal, and next it has long legs and is tall. Is tall, right? That's why height equals to tall, and it has long legs. Next one. Next one is a parrot is a bird and is green in color. A parrot. So here parrot is a bird. Okay, parrot is a bird. That means parrot is an instance of bird, and right. Next one, and parrot. A parrot is a bird and is green in color. So parrot. So color of parrot is green here. Right. Next. So it comes under parrot. It comes under birds. Right. So that's like this. I have represented the knowledge using semantic. Okay. Now let me. So let us next. Let us present this in semantic network in another way. So like this, right? So here some information is missing here. As here, every man and woman are human who have two legs. But here I cannot represent man and woman who are humans have two legs, right? So that's why here can present the knowledge which was given previously like this. Okay, So living thing in a box. Next one, the properties with the dotted line. Property. PROP means property, right? Next one, they can eat and breathe in oval shape. Next one, uh, bird. Bird is a living thing here. Bird is a living thing. Animal is a living thing. Human is a living thing. Human property have two legs, and the categories of human are man and woman. Next here, here also one. Next one, the instrument. That means the that means his name is John, who is a man. Right? Next one, here animal. So giraffe is an animal and cat is an animal. And next one, properties of giraffe here. It is tall and it has long legs. Next one, properties of animal is it has skin and it can move. Next properties of cat is it has fur. Next property of bird is it can fly. Next parrot. So color of parrot is green and parrot is instance of bird. So like this I can represent the knowledge using semantic network in another. Right? These are the concepts connected with property links. And the previous one is uh, representation of knowledge using semantic network. This is also the representation of knowledge using semantic network only, but the concepts here are connected with the property links. Just I am changing the semantic networking with property links, right? Next one. Next topic. Knowledge representation using semantic network, right? So let us discuss about inheritance in semantic. Right? So the hierarchical structure of knowledge representation allows the knowledge to be stored at the high possible level of abstraction. Knowledge will be stored at the highest possible level of abstraction, which reduces the size of the knowledge base. To reduce the size of the knowledge base, we're going to represent the knowledge in the highest possible level of abstraction. Okay. Next one. So since semantic net is stored as hierarchical structure, that means hierarchical structure means from top to bottom, right? Right. So right. So so in order to reduce the size of the knowledge base, the knowledge will be represented or stored at the highest possible level of abstraction, right? So semantic net is stored as hierarchical structure. Semantic net is stored as hierarchical structure, and the inheritance mechanism is inbuilt and facilitates inferencing information. Okay, so here semantic net will be implemented in any programming language. So we can represent the semantic net in any programming language along with inheritance procedure implemented explicitly in that language. So here, in order to represent the knowledge using semantic nets, here I have here I have used Prolog. That means logic programming language. Prolog means logic programming language. Okay, Prolog language means logic programming language. Okay, so it is very convenient to represent the entire semantic structure in the form of facts and inheritance rules. Now, let us discuss about Prolog. Right, Prolog facts are represented like this using semantic network. Right, so the Prolog facts here are the facts in the Prolog would be written as shown below. So here these facts are logic programming. Logic programming. Prolog means logic programming. Right? Next, so here the facts in Prolog are written like this. So easy facts on one side, instance facts on one side, and property facts on one side. So here we have represented all these concepts connected with property links. So all these are written in a table form, right? Right here. So easy facts. So living thing. So easy of living thing comma nil. That means none is there. Okay, that's why nil. Next one. So that means before living thing there is nothing. Before living thing there is nothing. That's why I have written it as nil. So easy of living thing comma nil means so it so that is the highest one. That is that is the highest possible level of abstraction. That is the first one. So living thing is the first one. So it doesn't come under anything. That's why I written as nil. Okay. If that is a if this particular living thing is a uh, sub part sub part, then I can write it as something. That means it is a part of this particular thing, right? Like that. Okay. That is the highest that is the highest level of abstraction node. I written like this. Okay. So easy of living thing comma nil. Next one, easy of human comma living thing. So human is a living thing. So human is a living thing. This one. Next one. Next one. Animals. So easy of animal comma living thing. Easy of animals comma living thing. Next one. The same way birds also. Easy of bird comma living thing. Okay. Next one. Next easy of man comma human. Easy of man comma human. Next one. Easy of woman comma human. And next one. Easy of cat comma animal. Okay. Like this easy relationship nodes are written on one side. And next one is instance facts. Instance. Here, how instances do we have? One is here giraffe. Next one John, giraffe, John, and parrot. So giraffe, John, and parrot. So instance of John, comma man. That means John is an instance of man. Means it is nothing but it is subpart of man. So it is subpart of man, right? Because all the names come under instances. All the names come under instances, right? So John is an instance of man. Next, instance of giraffe become an animal means giraffe is an instance of animal. Next one, instance of parrot comma bird means parrot is parrot is an instance of bird. Next one, property facts. Here the properties are here. One is a prop of breathe comma living thing. Prop of breathe comma living thing. Next one, prop of eat comma living thing. Right. Next one. Next, prop of two legs comma human. Prop of two legs comma human. Next one, prop of tall comma prop of tall comma giraffe. Prop of tall long legs comma giraffe. Like that. Okay. So this one. Next one, prop of skin comma animal. Prop of skin comma animal. Where is the skin comma animal? Oh, this one. So property of skin comma animal. Next property of move comma animal. This one. Next property of prop of fur comma cat. Fur comma bird. Prop of no, not bird here. Fur means it comes under cat, no, right? So property of fur comma cat. Next one, prop of tall comma giraffe. Prop of tall comma giraffe. Prop of long legs comma giraffe. Next one, and then prop of fly comma bird. Prop of fly comma bird. Next one, prop of green comma parrot. Of green comma parrot. So like this, all the easy facts, instance facts, and property facts are written. Okay. So this is how to represent the facts using Prolog. Prolog means logic programming. So full form of Prolog is logic program. So this is how to represent all the facts using Prolog programming language. Okay. Next, now let us see how to represent the knowledge using semantic network. That is the inheritance rules in Prolog. Now let us see what the inheritance rules that are to be used in Prolog. Okay, so we know that in class hierarchy structure, a member subclass of a class is also a member of all superclasses. That means superclass means the highest one. The highest one is the superclass, and the next level nodes are subclasses. Okay, so class, that means a subclass of a class. That means a member of a subclass of a class is also a member of all superclasses connected using EasyLink. That means whichever nodes are connected through EasyLink. So a member in the hierarchy structure, a member subclass of a class is also a member of all superclasses connected using EasyLink. Okay. Next, so that is the first rule. Next one. Similarly, an instance of a subclass is also an instance of all superclasses. That means here the two things are given. One is instance and easy. Easy means so whichever nodes are connected using EasyLink, all the members of a subclass of a class are also the members of all superclasses. And the second one is an instance of a subclass is also an instance of all superclasses connected by EasyLink. Here also the instance of subclass is also an instance of also. That means whatever subclasses we have in a class, so all the members of that particular class that are connected by either EasyLink or instance link, they will become the members of all superclasses. Okay, that's it, right? Next, similarly, a property of a class can be inherited by lower subclasses. That means all the lower subclasses can inherit the properties of class. Okay, so these are the inheritance rules in Prolog. Okay, like this. So instance rules are like this. Instance of x comma y means we can write it as instance of x comma y. Next, instance of x comma y can be written as instance of x comma z subclass of z comma y. Instance of x comma z comma subclass of z comma y. Next, subclass rules are subclass of x comma y equal to EZ of x comma y. Next, subclass of x comma y equals to EZ of x comma z subclass of z comma y. Next, in the same way, property rules are property of x comma y equals to prop of x comma y. Next, property of x comma y equals to instance of y comma z comma property of x comma z. Next one, property of x comma y equals to subclass of y comma z comma property of x comma z. So all these are the properties of inheritance rules in Prolog. Okay. So in the next class, we're going to discuss about this extended semantic networks for knowledge representation. Extended semantic networks for knowledge representation. So we will discuss this particular topic in the next class. Okay. Today only a few members are present. 62 members are present today. I don't know why. Yesterday 78 members were present. I don't know why there is a decrease in attendance today. So this particular attendance will be considered for your external exams also. So please be attentive and please attend the classes. Don't bunk the classes. Okay. So with this, I am stopping my class. So 10 minutes are remaining still, no? So okay. I thought it was 12:30. So I continue the class. I thought that it has become 50 minutes, but it is only 41 minutes, no? So to continue the class. Okay. So next topic is extended semantic networks for knowledge representation. So all the logic and semantic networks are two different formalisms that can be used for knowledge representation. So logic and semantic networks, these are two things with which we can represent the knowledge. So simple semantic network is represented as a so logic and semantics are two different formalisms that can be used for knowledge representation. So simple semantic network is represented as a directed graph whose nodes represent concepts or objects and arcs represent relationship between concepts or objects. So it can only express collections of variable free assertions. Now let's see one sentence here. John gives an apple to Mike and John and Mike are human. So it can represent in a semantic network like this. So both Mike and John, they're human beings. Human. And next, Mike is the recipient of E and John is an actor. Okay. So John gives an apple. John gives an apple to Mike. Not on here. So John gives an apple to Mike. John gives an apple to Mike. So John is an actor here, and Mike is the recipient. Next one. So here object for E is apple. Apple is an object. Apple is an object, and give is an action here, like this. Okay. Give means action. Apple is an object. So next one. Extended semantic networks for knowledge representation are represented like this. So binary predicate symbols in clausal logic are represented by labels on arcs of extended semantic network. So an atom of the form love of John, Mary. Love of John, Mary can be represented like this. So John, love, Mary. Okay. So it is a labeled arc. And is represented like this. So love with its two end nodes representing John and Mary. The direction of the arc of the link indicates the order of the arguments of the predicate symbol, which labels the arc as follows. So John, love, Mary. That means first John will come. After that, love, whom? Mary. So who loves Mary? So John loves Mary. That's why I have written like this. John, love, Mary. Okay. Next. So these are the order of arguments. Means the first order here is John, and the next order here is Mary. And the relation between John and Mary is love, like that, right? Next. So that means if love of John, Mary is given to us, then I can represent it like this. John. Okay. Next. Okay. Next one. So conclusions and conditions of clausal form are represented extended semantic network by different kinds of arcs. Okay. So the arcs denoting conditions are drawn with dotted arrow lines. So the arcs denoting conditions are drawn with dotted arrow lines. Conditions. That means if we have any conditions, then they are drawn with dotted arrow lines. Next, if you write like this, it is Daniel link. Daniel link. Next, while the arcs denoting conclusions are drawn with continuous arrow lines. So if I draw continuous arrow lines, it is the conclusion. Next, assertion links are represented using arrow mark. For example, the clausal representation of grandfather of x comma y, that means reverse arrow, father of x comma z comma parent of z comma y for grandfather. Okay. in logic. So this it can be represented in extended semantic network as below. X and Y are variables. Grandfather of X comma Y is the consequent of conclusion, and father of X comma Z and parent of Z comma Y are the antecedents or the conditions. Okay, that means X is the grandfather of Y. X is the grandfather of Y. Next one, father of X comma Z means X is the father of Z and Z is the parent of Y, and Z is the parent of Y, like this. Okay, like this, the sentence can be represented. Next one, so these are the inference rules here. These are the inference rules here. So action of f of x comma take, reverse arrow, action of x comma give. So this particular interpretation of the rule can be represented like this. So the functional terms such as f of x is represented by single node. Next one, the representation statement of action of f of x comma take and action of x comma give. So it can be represented like this: f of x action take, next x action give, like this. Okay, it means x action of q, next f of x action take, like this. Okay, and next one is extended semantic network representation is like this. So the inference rule that an actor who performs a taking action is also the recipient of this action and can be easily represented in causal logic. So like this. So E is a variable. It represents the event of an action of taking. It means recipient of E comma X. That means E is a recipient of X. And next, action of E comma take. That means E performs some action, that is take. And next, actor of E comma X. That means E is an actor of X. So I can represent it like this. So X is an actor of E. X is an actor of E. And next one, E is the recipient, like this. Next, E performs the action, which is nothing but take. Right? Next one. Next one. Next one is extended semantic network novel representation will be like this. So the contradiction in extended semantic network can be represented as shown here. So here P part of X is conclusion and P part of Y is condition. So P part of Y is condition and P part of X is conclusion. Next, Y is linked with X via is a link. Now it can be represented like this. Okay. So here P is a part of Y. P is a part of Y, which is the condition. Next, Y is the, that means Y is a of X. Next, P part of X. So this is the conclusion and this is the condition. Okay. And Y is linked with X via is a link. Next. So we'll discuss the remainder of this next. Okay. Thank you. But okay, we are in off. We don't have an off mode till now. Continuing in on mode only. So many students or more number of students will attend my class. Okay, thank you. So this I'm starting class. Thank you.